All right, today we're going to start chapter 11. We're going to talk about energy and its conservation. But for section 1, we're only going to talk about the two different types of energy that you need to know about for this course. And then we'll talk about section 2 in another video. So your question of the day today is, I want you to define energy in your own words. So make sure you go ahead and answer that on your question of the day sheet that you have in your folder. So section 1, the forms of energy. Now again, there are many different types or forms of energy. We're only going to talk specifically about 2 of them. The first of which is kinetic energy. We've talked about kinetic before. We've talked about kinetic friction and static friction. Kinetic is still that same term. So kinetic is going to be of something that's in motion. So energy that you get due to the motion of a system. And the units for all energy is going to be in joules. So how do we find kinetic energy? The formula that you'll see in your reference packet is kinetic energy, or KE, is equal to 1/2 of the mass multiplied by the velocity squared. So again, kinetic energy, that's measured in joules. Your mass should always be in kilograms. If it's not, you should convert. And you should have velocity in meters per second. Again, if it's not, you should go ahead and convert for that. So let's go ahead and look at an example. Your first example here is you have a 52 kilogram skater. They're moving at 2.5 meters per second, and they glide to a stop over a distance of 24.0 meters. Okay, I want you to find the skater's initial kinetic energy. So that means I want you to find the kinetic energy when they first start out. Okay, so what was their velocity when they first started out? The 2.5 meters per second, right? So here's our formula, KE equals 1/2 mv squared. And we just want to go ahead and plug everything in. So 1/2 times 52, that's our mass, times 2.5 squared. And when you plug all this in, you should roughly get about 162.5 joules. Now, if you'll notice, I did not use the 24.0 meters, okay? There wasn't a need for that in our equation. So just be mindful of what needs to go where and what extra information you may be given. There are some practice problems I do want you to add into your note page, just like we did with chapter 10. So page 706 in your iBook. It's number 2 through 4, and you can either stop the video now and go ahead and do those, or you can leave some space and come back to that at the end. Moving on, the second type of energy that we're going to talk about is potential energy. It's very similar to kinetic energy, only instead of energy of motion, it is stored energy, okay? And it's because of how objects interact with each other, and it's because of a height. So if you have potential energy, you have to have some object at some height being affected in some way. So units, again, we're still in energy. We're still thinking joules here. And there are 2 types of potential energy. There's gravitational and elastic. For this course, we are only covering gravitational potential energy, or GPE for short. So gravitational potential energy, GPE, it's because of gravity. So again, you have to have a height. That's very important for this. So let's go ahead and find GPE. This is our formula. GPE equals mgh. Okay, so GPE, that's our gravitational potential energy. It is measured in joules. Mass, again, always needs to be in kilograms. G, that's acceleration due to gravity. We haven't used that in a while. 9.8 meters per second squared. That's a constant. That's not going to change. And then H, that's your height, and that should be in meters. So let's go ahead and look at an example. You lift a 7.30 kilogram bowling ball from a storage rack, and you hold it up to your shoulder. The storage rack is 0.61 meters above the floor, but your shoulder is 1.12 meters above the floor. When the bowling ball is at your shoulder, what's the GPE relative to the floor? So here's our formula. GPE equals mgh. And go ahead and just plug everything in. Now we're measuring at your shoulder. your shoulder is 1.12 meters above the floor. So we plug in our mass, 7.3, plug in 9.8 for G, and plug in 1.12 for our height, because that's where the bowling ball is sitting at. Okay? And it says relative to the floor. So from your shoulder to the floor, that's 1.12 meters. So when you do that calculation, you should roughly get about 80.12. And again, that is in joules because it is energy. Now let's go ahead and look at another example with potential energy. Example 2, you have that same situation. All that first information is the same. Storage rack is still 0.61 meters. Your shoulder is still 1.12 meters. The bowling ball is still 7.3 kilograms. What I want to know now is when the bowling ball is at your shoulder, what's the GPE relative to the storage rack? Okay, so this is a little bit different. I don't want to know from 1.12 meters to the floor. I want to know from 1.12 meters to the storage rack, which is 0.61 meters. Okay, so same formula, but this time you need to find the height. What is the height difference between 1.12 and 0.61? So when you plug that in, and I've just plugged it in its own set of parentheses as 1.12 minus 0.61, and when you do that, you should roughly get about 36.49 joules. Okay, so again, pretty simple calculations. If I asked you to rearrange, it's pretty straightforward as to how to rearrange this. But that is pretty much it. There's some practice problems I want you to do for potential energy, page 713, number 5 through 9. And once you get finished with those, you have an assignment waiting for you. It's 11.1 review. And that's it for today.